Namaskar my dear friends. So as we were continuing with STM32 microcontroller application design, so we had seen some of the like interfaces, and we had seen this particular symbol as well, and what are the different peripherals that were connected, right? So some of the topics that were remaining in my previous session is we will be seeing like external interface like RS232, RS485, multiplexer switch, and UART to USB interface in this particular session. Okay, so how we are going to design this particular like interfaces, that we'll try to understand. Okay, so as you can see, we have already connected, let's say UART2TX and UART2RX, and then UART one more pair I have taken. Okay, so we'll try to utilize these two UARTs for our different application of RS232 as well as RS485 and UART to USB. Okay, so let us see first one. I have a USB, okay, which is micro B USB type, okay, and this is from Worth Electronics. So as you can see, it is shielded. Mainly my intention is what is my D plus D minus, which is basically USB positive and USB negative, and they have been protected to the ESD diodes as well. So TVS diode is there, which is this part number, which is 824011. Okay, this is the symbol that you can see, but the connection is pin number 3 is IO1, which you can see pin number 3 is connected here and pin number 4 is connected here. So the bus lines, which is D plus and D minus, has been protected, and the V bus is also protected through pin number 5. So this is a unidirectional TVS diode, very good one, which is around 24 kV, 24 kilovolt of protection capability. Okay, so this is the connection. Now this USB P and USB N will get connected to my USB to UART bridge device. So let us say one of the very good manufacturer for USB to UART bridge is Silicon Lab. Okay, so Silicon Lab device is there, which is newly introduced. Okay, so this USB P and USB N is connected to my D plus and D minus. That is one thing. Another thing is my UART signal is coming from microcontroller, which is UART2. I am using UART2 for this purpose. So this UART RX is connected to your TX of D. Okay, so this TXD is actually transmitting. So this USB to UART bridge is transmitting and getting connected to UART RX of my MCU. So this is going to my MCU UART, and UART TX, which is coming from MCU, is going to go to receive, and this receive will send it to this thing. So basically TXD RXD of this particular device is going to get connected with TX and RX of UART of your MCU. So this is the complete connection of UART to USB bridge. Okay, so this is one of the best application. Now moving to the RS485 and communication. So if you see RS485 transceiver, I have already explained about this particular device, which is ADM3061E. Okay, so this is one of the best device that is there from analog devices. Okay, so what is happening is my data out is going to get connected with UART RX, okay, and data in is going to get connected to UART TX. Okay, so two pairs were there from MCU UART, so I am going to take another UART TX and UART RX. Okay, so this UART TX is connected to data input, and this is going to get converted to RS485 transceiver signal, which will be in the form of like output at A and B. A is actually your non-inverting output and B is inverting output when it is acting as a transmitter. Okay, so it will act as transmitter as well as receiver both, based on the receiver enable and driver enable signals. Okay, so right now if you pull both of them up, so both of them are pulled up by default, so it is acting as a transmitter. Okay, you can see if both of them are high, it will act as a transmitter. If both of them are pulled low, then you have to utilize these two, and these two you can demount it, like you do not put it on the PCB. So that will then it will act as a receiver. Okay, so first we'll talk about transmitter. So once it is acting transmitter, this A and B are acting as a transmitter output. Okay, transceiver output. So this transceiver output is going to get connected to my D sub 9 connector, and it is going to work as RS485 transceiver. Okay, one more method what I have done is I have utilized two of the pins of my MCU PC8 and PC9, which will help you to configure this particular transceiver as a transmitter as well as receiver both. Okay. So if you want to act as transmitter, then you don't have to do anything. You can or otherwise you can put these two pins as high, so that they will act as transmitter. Then if you want them to work as receiver, then this will be A and B will act as receiver input. A will be acting as non-inverting receiver input and B will be acting as inverting receiver inputs. Okay, and in that case what will happen? PC8 and PC9 will be actually low, so that they will get enabled as receiver, and UART RX will start giving you the data out to your UART RX pin. Okay. So this is one of the very good understanding of RS485 transceiver. Let us say RS232. So RS232 communication is also used very prominently. Okay, so one of the device that I have used is from analog devices. Okay, so these are the two part numbers that you can utilize, MAX 3221 CAE and EAE. Okay. So very simple connection. I have already used this in my previous sessions, and in that you can see we have the UARTX that is coming from your MCU signal. Okay, so UARTX is going into your T1 in, and this is going to go as T out to your RS232 transmitter, and it is going to get connected to your D9 connector at pin number 2. Okay, similar to that, UART RX coming out, that is one R1 out, and it is going to come out from your UART RX signal, which is coming to the RS232 transceiver R1 input. Okay, and it is very simple design. You have to just utilize C1 plus C1 minus 1 0.1 microfarad capacitor, then C2 plus C2 minus 0.1 microfarad capacitors. So these are actually charge capacitors. You can utilize V plus and V minus. These two capacitors are also power capacitors for this particular. So those all four capacitors are 0.1 microfarad ceramic capacitors. You can keep the voltage rating of each one of them as 16 volt or 25 volt. Okay, even if you want, you can have 50 volt capacitors, because 50 volt are much more prominently available. Okay, but minimum 16 volt is needed. Okay, that is one thing. Now permanently it has been enabled, so the enable pin has been pulled low. Okay, and this is force off is also pulled up, so that it will not switch off, and force on is also pulled low, so it is always on. Okay, so this is how UART to RS232 transceiver is there. Now as you can see, this RS232 transceiver is also using same UARTX and UARTRX signal, and RS485 signal is also using UARTX UARTRX signal. Okay, so any one of them you will be trying to use. So in that case what you can do is you can utilize one switch. Okay, and that will help you to do this particular job. Either one of them can be utilized together. Okay. So in that case what you can do is, let us say I am going to change the signal. Let's say this is my MCU UARTX and UARTRX signal. Okay, that is going to come into the this 2:1 SPDT switch. Okay, single pole double throw switch. So single pole double throw switch means by default, okay, by default what is going to happen is, this is let's say pulled low. So when select 1 and select 2 both are 0, then D1 is getting connected to S1A and D2 is connecting to S2A. Okay, so this is how it is connected. Understood? Now as soon as select 1 and select 2 becomes high, so I am going to use one select line, SW switch select line from MCU. So if it is made high, okay, then what will happen is D1 will get connected to S1B and D2 will get connected to S2B. Okay, so this UARTX and UARTRX will get renamed as, let's say, TX RS232 and RX RS232. Okay, and these two signals will be coming as input of your RS232 signal TX and RX. So TX you put that, rename it to this one, and this one as RS232 TX and RS232 RX. Okay, similar to that, I will change it TX RS485 and RX RS485, so that it will get connected at the input of your RS485 transceiver, and you have to rename the input signal, or data out signal and data in signal of your UART signal as TX RS485 TX RS485 will be down one. Okay, TX RS485 to this one, and RX 485 to let's say RX RS485 and TX RS485. So this is how you have to rename these two signals so that you can utilize this particular switch to use one of the system like RS485 or RS232. So hope you have understood these three applications like RS485, RS232, as well as USB to UART connection and USB connections. Okay. So these were the complete package design for this particular device, which was STM32L053R8. So I have developed almost all the peripherals or all the applications that is needed for this particular microcontroller, and for developing any of the particular project, a complete package, if you want, you can try to use this particular microcontroller. And if you do have any questions or anything, you can always reach out to me. Now very best thing that I am going to tell you is, when you are going to utilize this USB connection, so for that purpose this VBus signal will be present. Okay, and in that case VBus signal is connected, then if you want, you don't have to utilize your power supply. Power supply will be automatically just by a jumper you will be able to utilize. So what will happen in that case, what you have to do is this VBus will get connected to this 5 volt supply by a jumper, and these two connection will, you have to just sort it, and once it is sorted, this 5 volt will be available, and this will get directly connected to here, so that it will give you 3.3 volt for your power supply of the complete board. Okay. So this PCB power supply will be available through this VBus. You don't have to utilize your external connector. And suppose if you do not want to use this VBus power for powering up the device, or maybe connecting to 5 volt as well as 3.3 volt, then you don't have to sort this jumper. You keep it open, and it will be connected through this external power supply, which is going to give you 5 volt output. Okay. So alright guys, if you do have any questions regarding the complete understanding of this particular microcontroller and the application design, and if you want any other peripherals to be connected through this like IO expanders or SPI other applications, let's say you have ADCs or DAC or any other interfaces, you please put down your questions in the comment box, and I shall be able to answer you out. In the continuation to this series, I will try to put more applications and more peripherals related to this particular microcontroller or any of this kind of microcontrollers, so that you have a complete understanding of your circuit design concepts. Okay, thank you.